Hello, and welcome to the sixth film about mole calculations. It's about stoichiometry and gases, so it's like the fifth one in that respect, but it's a little bit tougher, and it brings in this formula that you need to know in both year 11 and year 12, even though it's strictly a year 12 topic. This formula here, PV equals nRT. Okay, as I say, it's kind of extension in year 11, but it does come up on tests and exams, so it is worth trying to know it if you can. Okay, so this is the pressure in kilopascals. Oops, can't really write at the moment. So that's the pressure in kilopascals. This is the volume in litres. This is the number of moles, which we should be familiar seeing the symbol N for number of moles. Okay, this is the gas constant, 8.314. Don't try and remember that because it is on your data sheet. Okay, and this is the temperature in Kelvin. Okay, how do you find the temperature in Kelvin? You take the temperature in degrees centigrade and you add 273.15 to it. Okay, so it shouldn't surprise you to hear that you might have to rearrange this formula, but that's the meaning of all the terms in it, or those are the meanings. Okay, so here comes a practice calculation. How many litres of water can be made from 55 grams of oxygen and hydrogen at a pressure of this and a temperature of this? Okay, well, let's have a go. How many litres of water? We're being asked to find a volume. Here's our water, here's our oxygen, and we can see, hopefully, in a ratio, stoichiometric ratio, 2 to 1. Okay, so the number of moles of water is related to the number of moles. The volume of water, how do we find that? We can't use the formulas that we have been before because we're not at STP. So as soon as you see a question that's at different temperature and pressure to STP, then you have to use PV and RT. Now if we take that formula and rearrange it so that we've got V as the subject, we've got to divide both sides by P, and we end up with nRT over P. Okay. We know all these things because this one's on the data sheet, this one we're given, and this one we're given, and this one here is related to the oxygen, and we're told about the oxygen. So let's just write an expression for the number of moles of water and say how it's related to the number of moles of oxygen. Okay. This isn't true because one's 2 and one's 1. This one's bigger than that one, so the number of moles of water is bigger than the number of moles of oxygen, and it's twice as large. So we multiply the number of moles of oxygen by 2 to get the number of moles of water. Okay? What is the number of moles of oxygen? Well, we know that N equals little m over big M. So that is 55 over 32 for oxygen. And 55 over 32 is 1.72 if we're talking about 3 significant figures. Okay, so that means that the number of moles of water is twice that. Okay, which is 3. Okay, so we now know the number of moles of water and we can plug that into there. So volume is going to be 3.44 multiplied by 8.314 multiplied by that there plus 273.15. So that's 358.15 Kelvin. And we're going to divide that by the pressure, which is 200 kilopascals. Okay, that's what the answer is. And that is 51.2 litres. Okay, so there's our answer. Now that's quite a tough problem, okay, certainly by year 11 standards, because it incorporates this PV equals nRT, which is a 3A, 3B topic. Okay, it gets taught in year 11 as a bit of extension, and you should be aware of it because it can come up on your tests and exams. If you're year 12 watching this film, then really and truly you should treat this as quite a basic problem. Okay, so that's it for gas stoichiometry. The remaining two films are about limiting reagents. I wonder what the last slide might say. Well, while I'm thinking about it, I might just tell you, just be a little bit careful. If you're doing practice problems with gases, the definition of the molar volume, according to the datasheet, has changed recently. It used to be 22.41, it's now 22.71. So if you're doing problems like this, and you're getting answers that are close but not quite right, it could be that you're using a book whose solutions use the old value. Okay, it's 22.71 these days. You'll see 22.41 cropping up in quite a lot of old solutions.